This is Maths Linear Algebra Tutorial 8, question 7, part 22, A to D. We continue with the same exercise as before. We are given the following matrices A, B, P, D, which are n by n matrices, and we're asked to answer true or false with some justifications. The first question, 22A. If A is diagonalizable, it has n eigenvectors. This answer is false. The correct answer should be it has n independent eigenvectors for it to be diagonalizable. We now turn our attention to 22b. If A is diagonalizable, A has n distinct eigenvalue. And again, this answer is false. It must have n independent eigenvectors. The eigenvalues can be repeated, and even 0. But it must have n independent eigenvectors. 22c. If AP equals to PD, D is diagonal, then the non-zero columns of P must be the eigenvectors of A. This is true by definition, because what we have is A times the columns of V1, V2, and Vn must be equals to the same vectors V1, V2, and Vn, multiplying by D, the diagonal matrix containing the eigenvalue, because this is talking about A times Vi equals to lambda times Vi, and when we put it onto a matrix form, it will look exactly like this. So the answer is this is true. The last question is very similar to the previous question of 21D, where 21D was if A is diagonalizable, then A is invertible. Here it is opposite. It says if A is invertible, then A is diagonalizable. And the answer here is false. The reason is false is for A to be invertible, the eigenvalue cannot be 0. When it's diagonalizable, it does not matter whether the eigenvalue is 0 or not. All it needs is that it needs n independent eigenvectors. And the eigenvectors lambda can be 0. And that is the reason why this statement is false. Thank you.